Welcome back. All right, let's do some more with geometric sequences. So we're going to find the seventh term of the geometric sequence with the given terms. A2 is 768, A4 is 48. All right, so first of all, we have to solve for our common ratio. Okay, so remember, it's always going to be the later, oops, come on, go away, box. Got this, there we go. Box I can't get rid of. All right, so it's always going to be the later term here, and then for A1, we're going to substitute in the earlier term. And this is always the difference in the positions. And we do this whenever we are solving for R, for our common ratio. All right, so A4 was 48. So 48 equals 768 times R to the 4 minus 2 power, which is 2. So we have 48 equals 768 R squared. We're going to divide both sides by 768. All right, so of course I think this is going to reduce. All right, so 48 go in evenly to 768. It does. That would be 1/16. That would be 1 over 16. All right, so 1 over 16 is R squared. So we're going to take the square root of both sides. And we know that when we're solving for a square, we take positive and negative. So that means plus or minus 1/4 is equal to R. So it could be that R is 1/4 or R is negative 1/4. No real way to tell with the terms that we're given. So we'll consider both the positive and the negative values in solving for R. And I don't think I gave myself a little bit of space on the next page, but we'll solve for R. And then I've got the evaluating on, not for R, for A1. We'll solve for A1, right? And then we'll evaluate on the next page. All right, so let's consider both the positive and negative values for R. This one will be the positive. This one will be the negative. All right, so we have, and remember when we're substituting here, now we have any term. So AN is our any term. N is its position. So in this case, I'm going to use, well, it really doesn't make a difference, but I think I'd like the smaller exponent. All right, so I'm going to take the 768 just so I can have the smaller exponent. All right, and then we're solving for A1, that's our unknown, and of course our R is, I'm going to solve it twice. 3, excuse me, that's the last problem. That was on the last podcast. So A1 is what we're looking for, is 1/4 or negative 1/4. All right, so 768 equals A1 times 1/4 times 2 minus 1. All right, well, that's not so bad because that's just going to be 1/4. So 768 equals 1/4 A1. We'll just multiply both sides by 4. All right, so that means that our A1 is going to be 768 times 4, or 3,072. All right. So for the positive case, we have AN equals, so this is our rule, 3,072 times 1/4 to the n minus 1 power. Okay. Let's take a look at the negative case. All right, so everything is going to be the same, except R is going to be negative 1/4 this time instead of 1/4. So 768 equals A1 times negative 1/4, and we have 2 minus 1 power. So now we have 768 equals A1 times, so this is going to be negative 1/4 to the first power, so that's just going to be negative 1/4. So now we're going to multiply both sides by negative 4, and see now we're going to get a different A1, so our A1 here is going to be negative 3,072. So in this case, our rule would be AN equals negative 3,072 times negative 1/4 to the n minus 1 power. So we have two completely different rules, and they both work for that sequence. Right? That's what happens when they're an even number of spaces apart. So that when we take the root, we have two solutions. Let's evaluate both of these for A7. I have that on the next page, all written out, just to save us a little bit of time. All right, so here it is. So we have the positive and we have the negative. Whoops, but I see something is missing on mine because we had two solutions and it was a negative. So we'll go, that would be a negative and that would be a negative, but that's the last time because, well, when we raise that to the 6th power, that's going to be positive. All right, so let's take a look at this one. All right, so we have AN equals 3,072 times 1/4 to the n minus 1 power. All right, so we want to find the 7th term, so I plugged in 7 for n. And as I told you, don't make this a horrible looking little decimal that you have to, because you can't round on these. You know, this is an exact position, or exact term. You can't round the term. All right, so instead, keep it as a fraction and raise the numerator and the denominator to the power. You'll be able to reduce. It's much nicer. Look how nice that is. All right, so much better. All right, and I even show you a little trick there in terms of reducing. All right, so, and I'll show you how I got those numbers at the bottom there. All right, so we have now AN equals 3,072 times 1/4 to the 6th power. So 1 to the 6th power is 1. 4 to the 6th power is 4,096. So when I multiply that, I have 3,072 divided by 4,096. Now, we already know that 4,096 is 4 to the 6th power, right? We just calculated that out, right? Just a minute ago, right? There's 4 to the 6th power, 4,096. On the previous page, right, we multiplied 3 times 4 to the 5th power, right, to get 3,072. It was over here, right? I had, no, actually, we didn't do that there. That's right. We did have to multiply that, but let me show you how you know that that was going to be 3 times 4 to the 5th. So I forgot. We didn't actually multiply that one out. But we did just multiply 4 to the 6th. All right, so if we have 3,072, right, you might notice it's divisible by 2, but that's going to take you a little while. You might notice it's divisible by 3, because 3 plus 7 is going to be 10, and 10 plus 2 is 12, and 12 is divisible by 3. So is 3,072. So if I divide this by 3, right, I'm going to get 1, right? And then continue on, I'm going to get 0. And then I get 1 again, 2 again, or 2. And then we get 4. 1,024. Well, we've seen this a couple times. And that's actually 4 to the 5th power. And if you weren't sure, right, you might say, well, it looks like it might be multiple, divisible by 4, right? And if I divide that by 4, I would get 256. And 256 is 4 to the 4th power. And if you didn't realize that, you can divide it again by 4, right? And 4 goes into 256 64 times. Well, 64 is 4 cubed. But just in case you didn't recognize that being 4 cubed, you could break it down again and one more time. And you can see we have 5 4s and 1 3. So I could rewrite that as 4 to the 5th power. So now I have 4 to the 5th power and 4 to the 6th power. Well, I can cancel out 5 4s from both the numerator and the denominator, leaving me the 3 in the numerator and the 4 in the denominator. 3/4 is actually our answer. So it looked like it might be something awful, and it really is just a little 3/4. You're going to get the exact same thing on the other side, except it's going to be negative 3/4. So when you raise negative 1/4 to the 6th power, you're still going to get the exact same number, 1 over 4,096. Right? And then you could reduce that, but because your A1 is negative, we're going to have a negative answer. So here we could have two different possibilities for A7 depending on which of these rules is correct. And actually there's no way to know which one is correct. They're both correct. They're equally correct. I'm going to do this problem in class, and I'm going to do a couple more with writing the rules. I'm going to do that one in class. We'll talk about that. Let's do a couple more with writing the rules. All right, so here we have a geometric sequence, and we want to find the common ratio and write the rule. All right, so this in this case, we have all of the information we need. So this is super, super simple. All right, so I actually added stuff in here that I didn't even need. Right? We're just here writing rules, right? We already have the common ratio and we have the rule, so these are super easy. Let's do them in class because they're so easy. We can do that one in class. And I got that one, so I got 1, 2, and here I have some terms, 3, 4. So let's actually do a couple of those, even though they're really super easy. Because I'm afraid that's too much for in class. So we'll do the easy one. Oops, I just passed it. We'll do this nice easy one really, really quick, and I don't need all this stuff up here. We're just going to write the rule. We already have the common ratio and A1. That's given to us right up here. I can move that right there. Let's do that. All right, so I forgot I'd given this these nice, easy ones. So we're going to write the rule over here, and we're going to write the rule over here, and this is going to take no time at all. This is so simple. So AN equals 4 times 3 to the n minus 1 power. That's all there is to it, because we have everything. And the same thing over here. AN equals negative 16 times negative 1/2 to the n minus 1 power. Oh, we're done. That's all there is if you're given R and A1. There's just no work to do. There's a teensy-weensy bit of work if I give you the sequence, all right? So we're going to do this twice, one for each of these sequences. Our A1 here is given to us. It's 2. To find our common ratio, you just take any 2 successive terms. I'm just going to take the first 2. So if I take A2 and divide it by A1, it's always later over earlier. Right? So that's going to be our ratio here is going to be negative 6 divided by 2. That's negative 3. That's all I needed to do because the rule is just going to be 2 times negative 3 to the n minus 1 power. Ta-da! We're done. Let's look at the next one. All right, so we know A1, that's 10. Our ratio is just going to be A2 divided by A1. A2 is 5. A1 is 10. That's 1/2. Right? So that means our rule, AN equals 10 times 1/2 to the n minus 1 power. Ooh, so hard, right? That was easy. Right? Super easy. Right? And here we have 2 different terms, right? And so we're going to have to solve, right? So we have 1 of those and we have 2 of those. And I'll do those and the word problems in class with you. And so I think I'm going to end this podcast. Maybe I'll do, should I do 1? No, I'll do those in class with you. So I am going to end this podcast. All right, so as we have done quite a few problems. So I'll see you in class and we'll do the last couple problems.